let's learn about the properties of parallelograms. So first we'll talk about what is a quadrilateral, then we'll get into what is a parallelogram. There are 6 properties of parallelograms we're going to learn today that you need to know. Make sure you write them in your notes. And then we're going to do 3 special parallelograms, the rectangle, rhombus, and square. So let's get ready. You're going to need notes, pencil, and a calculator. I do want you to take notes. I want you to draw the labeled picture, write any definition, and then the properties down into your notes to be ready for our class. So take a look at all these shapes, and I want you to figure out which ones are quadrilaterals. You can pause it. Okay, so quad means 4. So anything that has 4 sides. So this is 1, 2, 3, 4, 5. This is 5, so this is not a quadrilateral. This is 1, 2, 3. That has 3, so that is not a quadrilateral. This one is a trapezoid that has 4 sides. This one is a rhombus, 4 sides. We have a square with 4 sides. Parallelogram. Our rectangle has 4 sides. And this one is called a dart. And that's 4 sides. It looks different because this one's concave in. The other ones are all convex. So we're really not going to concentrate too much on a dart, but on the other ones, that's what we'll be learning about in the next few classes. So a quadrilateral is a 4-sided figure. All of the edges have to be straight. It can't have something that's curved like that. That would not count as a quadrilateral. And it has to be closed. It can't just be open. So what happens when you make both pairs of opposite sides parallel? So you have some side, 4-sided figure, and then you make opposite sides parallel. So remember our parallel marking is the arrowhead. And if I write that statement, that's segment AB is parallel, it looks like the number 11, to segment CD. So basically the left and right side are parallel. Well, if I want the top and the bottom to be parallel, I'm now going to use the double arrowheads, and we can say that BC is parallel to segment AD. So as soon as you have a 4-sided figure and you have 2 pairs of opposite sides parallel, then that's going to become a parallelogram. And once you do it, a lot of other properties happen. So you need to be familiar with the parallel markings here and the parallel notation. So let's take a look. These are the 6 properties of parallelograms. I recommend you pausing it here, writing the properties down, and then come on back and then mark up the picture the way that I do. So the first thing, it has to do with the definition. Both pairs of opposite sides are parallel. So I'm going to add those marks back on. And we have parallel. Both pairs of opposite sides are congruent. Okay, so congruent marks are different. So I'm going to do 1 slash, 1 slash. The sides are congruent. And then up top, 2 slash, 2 slash. So be careful because those mean 2 different things. We're looking at congruent there. The third one says both pairs of opposite angles are congruent. So that means angle A, angle A is congruent to angle C. I did 1 arc. And then angle B, I'm going to do 2 arcs because it's not congruent to angle A. So 2 arcs for B and 2 arcs for D. They're opposite. They're across from each other. Those are going to be congruent. So opposite angles are congruent. Notice I had both, but now this is 1 pair. And it just means that that is enough to say, it could be 2 pair, but that's enough to say it's a parallelogram. If 1 pair of opposite sides are both congruent and parallel, like this, then if that's all I knew, then that would be enough to say that those are parallelograms. Consecutive angles are supplementary. We've got a lot of vocabulary words there. Consecutive means next to. Kind of. It's not quite adjacent. It's like the next one over. And then supplementary, we know, means adds to 180. So that means in my picture that the measure of angle A plus the measure of angle B equals 180. This angle and this angle equal 180. They're not congruent. They could be. They could both be 90, but they're going to be supplementary. B and C are supplementary. C and D are supplementary. D and A are supplementary. And that should make sense to us because if we look at the top as a parallel line BC to the bottom AD, and then we have AB as our transversal, those 2 points, those 2 angles, those are same side interior. And if you remember from parallel lines cut by a transversal, same side interior, add to 180. And I have added way too much to my picture. I'm going to erase just a little bit. Just get out of the middle a little bit. All right, and then the last one has to do with the diagonal. So once I draw those, I have diagonal as a segment BD and diagonal AC. They are going to bisect each other. It does not mean that all 4 pieces are the same. I've already used 1 mark and 2 marks, so I'm going to do 3 marks. Those 2 pieces are going to be the same. So if I say this is M, that means AM equals CM. And then I'm going to do 4. 1, 2, 3, 4. 1, 2, 3, 4. So BM is congruent to MD. Lots of information there, like every marking that we've done so far this year. So now let's talk about special parallelograms. So we just defined what a parallelogram is, and it has all of those 6 properties. Well, these 3 things below it, these 3 shapes below it, are all parallelograms, so they share all those same properties. A parallelogram is a rectangle. A parallelogram is a rhombus. If you notice my colors, I tried to go with yellow and red, and then together they make orange. So if you kind of put a rectangle and a rhombus together, you're going to get a square. So all 3 of those are parallelogram, and all the properties hold true. Now let's look at them individually. So with our rectangle, it is a parallelogram. So I know all those 6 properties are true. And if you think to yourself, what's the definition of a rectangle? You might be thinking, well, usually 2 short sides and 2 long sides, but that's not actually what defines a rectangle. It's 4 right angles. So I can add that to my picture. Oops. Ooh, that's not what I wanted. There we go. 4 right angles. When I draw the diagonals of a rectangle, yes, from a parallelogram, they're going to bisect each other. But now I've kind of taken that slanted, tilted parallelogram and I've straightened it out. So what happens is the diagonals are going to be congruent. So they already bisected each other and now they're congruent. So that means all 4 of those pieces are going to be the same. If we look at a rhombus, I need to get a different color here. A rhombus is a parallelogram with 4 congruent sides. So while a rectangle is about an angle, the rhombus is about the sides. So I can mark that up. 4 congruent sides. It is still tilted like a parallelogram. Because it's still tilted like a parallelogram, once I draw the diagonals, that's the longer one, that's the shorter one. They still bisect each other. That's my reason from a parallelogram. But now the thing that happens is they're going to be perpendicular in the middle. So we're going to say perpendicular. Remember the upside down capital T means perpendicular. And they bisect their angle. So they're going to cut that in half and cut that in half. And then 2 arcs here, because not all of them are the same. So they are going to bisect the angles. All right, let me get my blue. I said earlier that the rectangle and rhombus combine together to be a square. So you just combine all of these properties and you get a square. So if I go back to a rectangle that had 4 right angles, so a square is a parallelogram with 4 right angles and 4 congruent sides. So I'll mark that up. 4 right angles, 4 congruent sides. And then their properties of diagonals come together as well. So the diagonals are congruent. They're perpendicular, little all right angles all the way around, and they bisect the angles. So I already have the 1 slash, so I can go 2 slash. All of those are going to be equal. And I don't have enough room, but this angle would equal this angle, and I could put arcs all the way around. We do know that a square has a 90-degree angle, so all of these angles are going to be little 45s there. So lots of markings. A rectangle has 4 right angles. A rhombus has 4 congruent sides. And put them together, a square has both of those 4 right angles and 4 congruent sides. So let's try to apply some of these properties. Here we have parallelogram, and you would write this, you'd just write like a little parallelogram, A, B, C, D. Notice you don't draw it and then label it A, B, C, D. Like not across like that. You have to go around, so make sure you're doing that right. So I have segment AM equals 20. Well, that's this piece, that little part of the diagonal. I want to find the whole piece. Well, one of my properties say that the diagonals bisect each other, so AM has to be congruent to MC. So then that means MC is 20, and now I can see that AC is going to equal the entire thing, 20 plus 20, which is 40. Here we're going to look at some angles. So the measurement of angle D is 125, and I want to find the measure of angle A. They're not congruent. B would be 125. Opposite angles are congruent, but A and D are supplementary. So we're going to say the measure of angle A plus 125 equals 180. So the measure of angle A is going to be 55 degrees. And if you look at it, it's supplementary to that. It's also supplementary to that. Let's fill in what we know for our angle B. We've got 2x plus 10, and angle D is 3x minus 35. Those are opposite, so I can set them equal. So 2x plus 10 equals 3x minus 35. I want to find x, so I'm going to subtract 2x from both sides. 10x equals x minus 35. Still trying to get to the x, so I'm going to add 35 to both. And I get x to be 45. And our last example, here we have parallelogram with our diagonals drawn. AM is 3x minus 6. MC is 5x minus 22. I know it's a parallelogram, so those pieces are congruent. So we set them equal to each other. I'm going to subtract 3x. Negative 6 equals 2x minus 22. Add 22 to both sides. And we get 18. Nope. 16 equals 2x. Divide by 2. And x equals 8. I'm not done. They want me to find AC. So when I plug that back in, I can go into either one. So AM is going to equal 3 times 8 minus 6, 24 minus 6. That's where my 18 came from. So AM equals 18, and I want to find the full diagonal. So I'm going to multiply that by 2, and we get 36 for our final answer. So pay attention. Sometimes they're asking for the variable. Sometimes they want the piece. Also, try to figure out what your relationship is. Are they equal to each other? Do they add to 180? Those are most of what we're going to see. So, nice job.